In this video, we will try to understand what is EMF, terminal voltage, and internal resistance of a battery. For this, let us consider a battery or dry cell, you can say, where it is written as 6 volt. In the market, if you see the pencil batteries or dry cells, they are 1.5 volt, lots of markings are there. So whatever potential is printed, that is the EMF of the battery. In this case, suppose let us consider this battery where 6 volt is printed. It means EMF of the battery is your 6 volt. It means it supplies 6 joule of energy per coulomb. Let us try to understand, or let me explain it in some other way. What does it mean? Now, let me connect this by a conductor and say, you can say some bulb is connected here. Okay, some bulb is connected here. And then current will flow from positive terminal to negative terminal. As you know, as current flows, that means there is flow of charge. Charges does not flow, or charge does not flow automatically. Charges do not flow automatically. The battery make the charge to flow. So as you know, in a conductor, the free electrons move, and in the opposite direction, current flows. Say current flows I. Now you see. To explain it, let us assume, say positive charge flows. It's a positive charge, and it is your positive terminal of the battery. Definitely it will repel the positive charge. For this, the battery has to do work to make the charge move, or to bring the charge from this terminal to this terminal. And then it will push the charge, and it will push the charge. As the charge will come here, then it will go like this way. This positive terminal, then it will repel. That way you can think. Now see, in order to push the charge from this to this, the battery has to do work, because it's your positive terminal. Internally it will repel the positive charge. Now say this is your 1 coulomb charge. This is your 1 coulomb charge. Now, as the battery here 6 volt written, it can say 6 joule per coulomb. So to bring this 1 coulomb charge from this terminal to this terminal, the battery do 6 joule of work done. It means it supplies 6 joule of energy. As you know, amount of work done is energy. So it supplies 6 joule of energy. Now you may think that this 1 coulomb charge gains 6 joule of energy, but it does not happen actually. Because in a battery there are chemicals, there are some medium, and that opposes the flow of charge. And that's why there are some internal resistance which we represent by R. Due to this, some amount of energy is lost. For our convenience, say 2 volt, 2 joule energy per coulomb is lost. It means to bring 1 coulomb charge from here to here, due to internal resistance, 2 coulomb charge is lost. That actually 1 coulomb charge gains what amount of energy? 4 joule of energy per coulomb. That is your 4 joule per coulomb, or you can say 4 volt. It means यहाँ तक आते आते इसका एनर्जी कितना गेन किया? 1 कुलम चार्ज ने 4 जूल एनर्जी गेन किया, अर्थात 4 जूल एनर्जी गेन करिल 1 कुलम चार्जे. তেতিয়া হলে you can say in that case, at this terminal and in this terminal there is a potential difference of 4 volt. This is called terminal voltage. Now see, as it comes here, then it flows, the positive charge flows like this way, then again current flows, and it continues. We can take an example. In the park we have seen the slide, and suppose if a child, and if you push the child, the father keep on pushing the child up to this. After that, then automatically the child come down. So to bring the child up to this position, the father has to do work, and that from the ground level and to this top level, the father has to do work. After that, the child will, that means whatever amount of work the father has done, that amount of energy the child will gain, and it will come down, and that energy is converted into kinetic energy. Okay, the similar way, to bring 1 coulomb of charge the battery has to do work because it is positive terminal, it will repel this positive charge, then it will push the charge, the battery will push the charge, and then it will bring up to this. And in doing so, due to internal resistance, it loses some amount of energy, say 2 joule energy lost. That means then what amount of energy the charge will gain? 4 joule of energy charge will gain. Now you see, that is 4 joule energy per coulomb, that is nothing but your 4 volt, that is nothing but your 4 volt, equal to EMF was how much? That is your 6. EMF was 6. What amount of energy loss? That is your 2 joule per coulomb. That is your 2 joule per coulomb is nothing but volt. That is your 2 joule per coulomb. It is like this. And this 4 is your terminal voltage. মানে এই টার্মিনাল আর এই টার্মিনালর আমার potential difference 4 ভোল্টে থাকি যাবে. So that's why you can say that is VT, terminal voltage. Let us generalize the case now. Terminal voltage VT equals to 6 is your EMF which was printed on the battery, that is your E, minus this is your loss of energy, and it is actually in the form of heat. The lost energy dissipated in the form of heat. So what amount of energy is lost, or what amount of energy is converted into heat? That is nothing but potential drop. Internal resistances are, say, I current flows, then potential drop is what? That is your IR due to the cell. So that's why you can say VT equals to E minus IR. This is the relation between terminal voltage, EMF, and internal resistance. I hope I could make it clear to you. Thank you.